This lecture is about how to do calculations with significant figures. I'll go over how to correctly record significant figures in your answer when you're performing addition and subtraction, multiplication and division, and I'll also go over powers and roots. When you're adding or subtracting numbers, you have to always round the answer to the same number of decimal places as the value with its rightmost significant figure in the greatest decimal place. So I'll give you a few examples of what that means. In problem number 1, I have 4.03 plus 5.4. If I look at the rightmost significant figure of both numbers, in the first number it's in the hundredths place, and in the second number it's in the tenths place. The tenths place is greater than the hundredths place, so I'm going to have to round my answer to the tenths place. So when I add these together, I get 9.43, and rounding to the tenths place gets me 9.4. So that would be the correct way of recording that result, and respecting the significant figures. In problem 2, I have 510 minus 418. And you'll remember that because we don't have a decimal, that 0 in 510 doesn't count as significant. So because that's bigger than the ones place where the 8 is at, that will be the place where I round to when I do the subtraction. So I subtract, and then I round to the tens place, which gives me 90. In problem 3, I do have a decimal point in both numbers, so those zeros in 4300 are significant. So I'm going to have to round to the ones place in my answer, which gets me 4418. In problem 4, the first number goes down to the thousandths place, and the second number goes down to the hundredths place, so I need to round to the hundredths place. So I need to round to this, which gets me 0.06. Problem 5 is written in scientific notation, so I'm just going to rewrite that just so I can see a little bit more clearly which decimal place each number goes to. I can see that the left number goes to the tens place, and the right number goes to the hundredths place, so I'll round to the hundredths place. Problem 6 is also in scientific notation, and if I want to rewrite that in scientific notation, this is how it would look. In problem 6, I'm subtracting two numbers in scientific notation, and I'll rewrite them so it's a little more clear, so I can see that first number is in the hundredths spot, and the second number is in the hundredths spot, so I'll round to the hundredths spot. So that would be my answer. Moving on to multiplication and division, the rule works a little differently. When you're multiplying or dividing two numbers with significant figures, you have to round the answer to the same number of significant figures as the value in the problem with the least number of significant figures. So I no longer care about the decimal place, I only care about the number of significant figures, and I'll always round to the least number. In problem number 1, the first number has 3 sig figs and the second number only has 1, so I need to round my answer to only have one significant figure, because that's the lower number of sig figs. So when I round that, that comes out to be 60. Problem 2 is division, and I have 4 sig figs in my numerator, and because that decimal point is there in the 30, I have 2 sig figs in my denominator. So I have to round the answer to 2 significant figures, so that would be the answer. In problem 3, I have a number with 2 sig figs and a problem with 3 sig figs, because again, that decimal point is there. So that means I have to round this number to 2 significant figures. So this could be 440 with a decimal point after, but the problem is that that decimal point is making that 0 significant, so I actually have to remove that decimal point so that the 0 is no longer significant and I only have 2 significant figures. In problem number 4, I have 2 sig figs over 3 sig figs, so I'll round to 2. In problem number 5, I have 3 sig figs times 5 sig figs, so I'll round to 3 significant figures. Finally, in problem 6, we're doing a division where we have 4 significant figures over 4 significant figures, so my answer will also have 4 significant figures. So this will be my answer. Rounding that to 4 sig figs gets me 0.8978. So that's how you do multiplication and division while respecting significant figures. Finally, we can go on to powers and roots. The rule here is to round the answer to the same number of significant figures as the number being raised to the power or root. So we'll go through the examples. In example 1, I have a number with 3 significant figures being raised to the 4th. So I raise it to the 4th power, and then round it to 3 significant figures, and this is what I get. In problem number 2, I have a number with 2 significant figures, and we're taking the square root. So I know that the square root of 16 is 4, but my answer has to have 2 significant figures in it. So to add more significant figures, I'm going to rewrite this number as 4.0. That would be the correct way of writing it so that it still has the same number of significant figures as the original number. In problem 3, this problem has 3 significant figures. So raising that to the third gets me this, and I'll round it to 3 significant figures, and this is my answer. In problem number 4, this number only has 1 significant figure, so when I take the square root, I have to round this to just 1 significant figure as well. Number 5, we have 4 significant figures. So rounding that gets me this answer. And in problem 6, I have 2 significant figures. So taking the cubic root gets me 2.1 times 10 squared. So that's how you do calculations while respecting significant figures.